Okay, so today's notes are on inequalities. Our content objective is to solve and graph inequalities and compound inequalities, and our language objective is to use the correct terminology to describe and explain inequalities. So in order to do that, we're going to start with a key concepts overview. So first thing I want to talk about greater than, less than, greater than, equal to, less than, equal to. So I'm going to draw a little table here, and I'm going to start with x is greater than 4. So this is read as x is greater than 4. And if I graph this on a number line, we'll put 4 right in the middle. Because it's greater than, first of all, it's an open circle. So if it does not include the point, it's open. So it's just greater than, not greater than or equal to. Open because it does not include the point. And greater than means going in the positive direction on the number line. So if this is 5, this is 3, it's going greater than that value. Similarly, if I had x is greater than or equal to 4, it's read as x is greater than or equal to 4. Then again, I'd have my number line with 4. This time I'm going to have a closed circle because it could be equal to, so it includes the point, and that would also go in the positive direction since it's greater than. Other two go the other way, so we'll draw a little line in there. So if I had x is less than 4, again, x is less than 4, then you'd have a number line, you have 4, open circle because it's not equals to, it's just less than, and then an arrow going towards the negative direction because it's less than. So the variable that you're trying to write the solution set for is going in the lesser direction. The last one is x is less than or equal to. So the equals to have a line underneath, they have closed circles, they're read as x is less than or equal to 4. And on your number line, you again have a closed circle because it could be equals to, but then it is pointing in the negative direction. So that's the overview of our inequalities. Other than that, solving inequalities is just like solving equations. The only thing you need to remember when solving that's different than an equation, besides the graphing, is that when you multiply or divide by a negative, you switch the inequality. So inequalities, you solve just like equations. But, so it's a bracket, but switch the direction of the inequality when you multiply or divide by negative. It's the only other thing you have to remember. So I'm going to do a quick example. What is the solution? Of negative 3 parentheses 2x minus 5 plus 1 is greater than or equal to 4. So this is going to be our really quick example. First thing I'm going to do, step 1, since I'm solving just like an equation, I'm going to distribute. So I'm going to distribute that negative 3 in, and I get negative 6x plus 15 plus 1 is greater than or equal to 4. Then I'm going to combine like terms. So 15 and 1 become 16. Then I'm going to isolate x, which means I subtract 16. So negative 6x is greater than or equal to negative 12. And I divide by negative 6. Since I do that, I need to switch inequality direction. switch the inequality. So this becomes x is less than or equals to 2. So my solution is x is less than or equal to 2. My last step should be graphing my solution set. So I make my number line. I'm going to put 2 in the center since I'm starting fresh. It's going to be a closed circle. Put 1, 3. And since x is less than x, my arrow always represents my solution set for x, or the values that would work for x. So x is less than 2, so it's going to be pointing in the negative direction. All right, for the sake of time, I'm going to keep cruising along. So I'm going to flip the page for the next example. One quick thing, can have always true, never true, sometimes true, and never true inequalities. So always true is if the variable, so I'm going to make a quick table. Always true, sometimes true, and never true. And always true, the variable cancels out when you're solving. So when you're solving, the variable cancels, but the resulting inequality is true. So for example, that could be if you solve out and you get negative 15 is less than or equal to 8. That's true. Negative 15 is less than or equal to 8. So this would be an always true inequality. So keep that in mind. Sometimes true is going to be the ones you're used to solving, so variable doesn't cancel. And so the resulting inequality is your solution. So an example of this could be, like we just got, x is less than or equal to 2. So there's still a variable, so my solution set is that x is less than or equal to 2. Never true, again, the variable will cancel, but the resulting inequality is not true. So it is false. And in that situation, it might look something like negative 2 is greater than 7. There are a million or thousands of examples, but negative 2 is not greater than 7, so this would be a false, so that would be a never true inequality. So we have always true, sometimes true, and never true in these situations. All right, now we're getting into the good stuff. So compound inequalities is what we're going to talk about next. So compound inequalities, one of our important vocab terms for today, are two inequalities joined with the word and, so we have and inequalities, or the word or. So we have and or inequalities. We're going to start with and. So our first one, and inequalities. This means our solution set makes both inequalities. So the two that are joined together, it makes both of the inequalities true. So your solution results in a bounded line, so results in a bounded section of the number line. So I'm going to do an example to show you what that looks like. So our example, what is the solution of 7 is less than 2x plus 1 and 3x is less than or equal to 18. So first step, we're going to solve each inequality. For x. So if I start with this one, 7 is less than 2x plus 1. I subtract 1 from both sides. I get 6 is less than 2x. I divide by 2. And I get 3 is less than x, which I can flip around. So if I read this backwards, x is greater than 3, so I can write it that way. Or 3 has to be less than x. So this is my solution for the first one. I'm going to do the same with the second one. It's a little bit quicker. So I have 3x is less than or equal to 18. I divide both sides by 3. X is less than or equal to 6. So these are my two selections that I need to now combine. So I solved both my inequalities. Step 2, I'm going to draw a number line only with solutions, or sorry, draw a number line for the answer with solution sets. So I'm going to draw my number line with both solution sets to start. So I'm going to put 7, 6, 5, 4, 3, 2. My first one is an open circle, and it's going to be greater than, so it's going this way. My other one is a closed circle at 6, and it's going to be less than, so it's pointing this way. My actual answer to this solution set is the line that is bounded by these two endpoints. So draw the number line with only solutions that work for both. So my answer is only the number line that includes the selection, so between 3 and 6, that section that works for both of them. So I have 3, 4, 5, 6. This end is 6 is a closed circle, 3 is an open circle. So my answer is actually this number line. I don't want the arrows to continue in both sections. I want it to be bounded because it's only the solutions that work for both. The other thing I want to note for this is you can write this inequality with the lower bound and upper bound as one long string. So I could write this as 3 is less than x, which is less than or equal to 6. So the same way your visual number line is bound, you can write the inequality bound in the same way. So we can write a bounded solution when it's an and inequality. This will not work for or inequality. So I'm going to flip the page for our or inequality. Our or inequality works differently. So last one, the solution had to work for both. So it had to work for one and the other one. Or on the other hand, makes one of the two, or one of the two inequalities true. And it results, instead of having a bounded selection, it results in arrows pointing in opposite directions. So our other one was bounded. This one's going to have arrows in opposite directions. So really quick example, I know this is taking more time than I had planned. What is the solution of 7 plus k is greater than or equal to 6, or 8 plus k is less than 3? So really quick, we're going to solve both inequalities. So I have 7 plus k greater than or equal to 6. I'm going to subtract 7 from both sides. K is greater than or equal to -1. That's my first one. I'm going to do the same thing. 8 plus k is less than 3. Subtract 8 from both sides. I get k is less than -5. So those are my two solutions. I'm going to graph them. So when I graph them, I have -5, -4, -3, -2, -1. Here at -1, I have an closed circle, and it's pointing in the positive direction. The other end, I have an open circle. It's pointing in the negative direction. So as you can see, we ended up with opposite arrows. Or inequalities cannot be written as a chain, so you have to write the final answer as a solution, two different inequalities as a set. But that is your answer. That's all you have to do. All right, that's it for today. Make sure you write down any questions, comments, or concerns you have so we can go over them together in class.